Hello everybody, my name is Chidar and I'm assistant professor at Mid Sweden University. My research focuses on advanced trustworthy AI for beyond 5G and industrial IoT. I also had the opportunity to do research teaching at Nanyang Technological University in Singapore, supported by Vinova funding to develop advanced trustworthy AI solutions for 6G networks and industrial applications. In addition, currently I'm part of the Trust project also funded by Interact Aurora, which work on building secure and reliable AI system. Today, I would like to deliver a lecture series on explainable AI, an important part of trustworthy AI. There will be 3 units. Unit 1, why explainability matters. Unit 2, white box, black box, and their method. And Unit 3, I would like to discuss about the application and future direction of the explainable AI. On this slide, you can see some recent headlines about AI. They highlight the challenges and risks that come with using AI in critical areas. For example, the EU is pushing for stronger regulation to make sure AI models with systemic risks follow the rules. A study in England showed that AI tools sometimes downplays women's health issues, which raises fairness concerns. In Australia, research has shown that AI used in job interviews can introduce discrimination risks. And in the legal field, we see AI hallucination in court documents, which can cause serious error. All of these examples remind us why trustworthy AI and explainable AI are so important. We need AI systems that are not only powerful, but also transparent and biased and reliable. This slide is about the European Union AI Act, which is the first major law focused on AI. Its goal is to ensure that AI is safe, trustworthy, and respect fundamental rights. The Act defined 4 risk categories. And acceptable risks, these systems are banned. For example, emotion recognition in school or workplace, one not for safety or medical reasons. High risks, these are allowed but under strict rules, such as AI for recruitment, promotions, or monitoring employee limited risks. These require transparency. For example, chatbot must tell user they are AI. Minimal risks. These face almost no restrictions such as AI for entertainment or spam filters. Overall, the Act pushes for a more user-centric approach, making sure AI serves people while reducing harm. This slide shows the key principle of trustworthy AI. Even though different organizations used slightly different words, the message is the same. Trustworthy AI should be first and unbiased. AI must not discriminate against people. Transparent and explainable. People should understand how decisions are made. Responsible and accountable. There must be clear responsibility for AI outcomes. Safe and secure. Systems should not cause harm and must be protected from misuses. Private. AI must respect personal data and protect it. Reliable and robust. The system should work well even under stress or unexpected situations. And finally, human focus. AI should be built to help people. So these principles are at the heart of the trustworthy AI, and they guide both policymakers and researchers in designing systems that people can trust. Here is the comparison between the black box and explainable AI. The black box model gives us results but no explanation. With an explainable model, we get both the result and the reason behind it. That makes AI more transparent and trustworthy. This chart shows how the explainable AI market is growing worldwide. In 2021, it was about $4.4 billion. By 2030, it is expected to reach $21 billion. This growth showed that explainability is not just a research idea, it's becoming a big business need. Industry want AI that is transparent, trustworthy, and safe. Different users need different kinds of explanation from AI. Experts like doctors or financial advisors need a detailed explanation so they can trust the decision and act on it. End users like patients or customers need a simple explanation. They just want to know why a decision was made and if it is unbiased. Regulators need explanation that show compliance with laws and ethics. AI developers need an explanation that help them debug and improve the model. Business leaders want explanation that links AI decision to risks and strategy. So explainability is not one size fits all. It should be adapted to the audience. When we talk about explainability in AI, there's a three types of explanations. For the first category, natures of explanations, some models are built-in explanation, which means they are interpretable by design. Others are post hoc, which means we explain them only after trainings. For the second, applicability, some methods are model agnostic, mean they can be applied to any type of models. Others are model specific, meaning they only work for a particular type of model. For the third category, it is the scope or explanation, where global explanation tells us how the whole model works. Local explanation tells us why the model made a specific prediction. So depending on the context, we might choose different kind of explanation, whether it's before or after training, for all model or just once, and at the global or local level. There are many ways to make AI models explainable, and they can group into a few main approaches. First, the model themselves. Some models are already transparent or easy to understand, like linear regression, decision trees, or rule-based models. Others are black box models like deep neural networks. For the second box, post hoc explainability. If the model is a black box, we can still explain after training using special tools. This method can be model specific for only one type of the model or model agnostic, working on any models. For the third box, categories of explanations, we can simplify the model, show which features are most important, give local explanation for single predictions, or use visual explanation to help humans see patterns. For the fourth box, principle and techniques. Principle including like feature importance, counterfactuals, sensitivity tests, or game theory ideas we can use. Techniques like include well-known methods like chef, line, anchor, PDB, or ICE. So depending on the models and the user need, we can choose different explainability methods, from simple model to the advanced tool. On the chart, models on the left side, like neural networks and random forests, are usually very accurate, but they are also hard to explain. On the right side, models like linear regression, decision trees, and simple rules are much easier to understand and interpret, but they are usually less accurate. So there is a trade-off. If we want high accuracy, we often lose interpretability. If we want easy explanation, we sometimes sacrifice accuracy. On the chart, models on the left side, like rule-based systems, logistic regressions, and decision trees, are easy to understand. They are simple, transparent, and interpretable, but usually less powerful. As we move to the right side, models like random forests, support vector machines, and neural networks become more complex. They are powerful and accurate, but much harder to interpret or explain. This shows the challenges in AI. Simple models, easy to explain, but less accurate. Complex model, more accurate, but harder to explain. As a conclusion, traditional AI often works as a black box, limiting trust and usability. XAI provides transparency, showing why and how decisions are made. Different stakeholders, user, developer, regulator, benefits in unique ways. Explanation build trust, enable error corrections, and support compliance. Explainability is the essential for trustworthy, human-centered AI. Thank you for your attention. If you have any question, please feel free to contact me at g.tar@mune.se.